Sir, are you speaking, sir?
Then we saw what is angular velocity. Then we discussed about the relation between. Then we saw the concept of time period, frequency. Then we try to express angular velocity in terms of time period and frequency. So how was it defined as? So angular velocity was omega. So how did we write omega as? Omega is equal to 2 pi divided by capital T, where time period, or omega is also equal to 2 pi into S. And what was the SI unit for this? Radians per second, right? So after angular velocity, we saw the relation between linear velocity and angular velocity. What was it? V was equal to R into omega, or V vector was also written as omega vector cross R vector. You remember this? Then we saw the concept of angular acceleration. So what is angular acceleration? It is represented by the symbol alpha. How did we define this alpha as? If you write alpha as a bar, it is written as d omega by dt. Delta omega by delta t. Whereas if you write it as alpha instantaneous, you write it as d omega by dt. So after angular acceleration, we saw one more acceleration, which was the most important one, which is centripetal acceleration. So what is centripetal acceleration? So basically, centripetal acceleration is the acceleration of the object which is always directed towards the center of it. Is that right? So, and what was the value of it? If I write this as AC, or some books refer to it as AR. Why AR is? AR I didn't tell you yesterday, make a note of it. AC, C stands for centripetal, or AR, R stands for radial. So centripetal acceleration or radial acceleration both mean the same. What was the value that we derived yesterday? So AC is equal to V square by R or R omega square. Both are of the same value. Right? Actually, this these three concepts. Right. Now, if you recollect it, I would have shown you the derivation of centripetal acceleration using. So the vector method, what did I do? I combined the concept of vector, coordinate geometry, and trigonometry along with the definition of theta. That is why you write it as r cos theta plus r sin theta. Check your notes. R cos theta plus r sin theta. R cos omega t plus r sin omega t. Then we go with the. Then we went to the procedure of differentiating it. So when you differentiate displacement once with respect to time, you got velocity. Which velocity was it? The tangential velocity. And when you differentiated the tangential velocity, I think you got the acceleration. And what acceleration was that? That would be centripetal acceleration. So if you observe, we would have got the final expression as AC is equal to minus omega square R. So if we get this one. So what does the minus sign indicate? That acceleration and R are in opposite direction. So if the radial vector is in this direction, acceleration is the opposite direction. It is always directed towards the center. Is there any doubt to this step? Is it clear?
Yes, sir.
Clear?
Yes, sir.
I have something important. So in the previous case, we saw the derivation of centripetal acceleration in terms of vectors and differentiation, right? Now we are going to see the same derivation for it in terms of vectors. I'm going to use triangle law of addition of vectors to derive the expression for the same centripetal acceleration. Okay? So for that, let's take the heading as centripetal acceleration. Now, let us consider a particle revolving in a circular path in this fashion, where we are considering the motion of the object between the points A and B, where the particle is traveling in the anti-clockwise direction. So it is rotating in the anti-clockwise direction, let's say with a constant angular velocity omega. Now, when it is revolving in this manner, if I say this to be the radius, and this will also be the radius, if I take the center to be the point O, where the radial vector which was like this, revolved in the anti-clockwise direction through an angle, let's say delta theta. So that the corresponding displacement that has taken place along the circular path is going to be delta S. Now, if you see, the velocity of the particle at A is going to be tangential in the upward direction, and the velocity at point B is going to be tangential inclined in this direction. Now, there comes an important question that we need to answer. If I observe O, if I call O to A as R1 vector, such that the magnitude of R1 vector is R only. Similarly, from point O to B, if I call this as R2 vector, such that the magnitude of R2 vector is also R only. Reason being, OA and OB represent the radius of the circle. Now, if I join A to B in this way, then if I call this as R vector, for instance, or I'll call it as delta R vector, that is a change in the radial vector that has taken place. So if I take that to be delta R, then delta R will be equal to R2 vector minus R1 vector. The logic is very simple. Why are we getting it? Because R1 vector plus delta R vector, according to the triangle of addition, R1 vector and delta R vector are the continuous vectors. So the sum of these two vectors should be equal to the third vector. Means if I write R2 vector is as the sum of R1 vector and delta R vector, from this if I rearrange, I get delta R vector is equal to R2 vector minus R1 vector, which I'll call it as equation number 1. So this is the extra information that you need to make a note of for understanding purpose. The next point that we need to observe is I have V1 vector. So if I take this V1 vector and place it here, I take this V1 vector and I place it here. In such a way, it looks like this. So this is V1 vector such that the magnitude of V1 vector is going to be V, because we are trying to derive the centripetal acceleration for the uniform circular motion. So the magnitude of V1 vector is V. Similarly, if I take this V2 vector and place it here, then this V2 vector will be like this. I repeat it. So I take this V2 vector, I move it in this way, I exactly. So this vector and this vector have some inclination between them. What is that inclination? We are supposed to find it. Okay. Now, if if I join these 2 points, then this is going to be delta v vector, which is the change in velocity that has taken place. Right? So here 2 important points are to be noted. That is, the magnitude of v1 vector is v. Same is the case with magnitude of v2 vector also, because the particle is undergoing a uniform circular motion. So if this is going to be v2 vector, then magnitude of v2 vector is also going to be equal to v. Having these 2 points in mind, we can say v1 vector plus delta v vector is equal to v2 vector. So v1 vector plus delta v vector is equal to v2 vector according to the triangle of addition. So from this I can conclude that delta v vector will be equal to v2 vector minus v1 vector. Let me call this as equation number. Important point that is to be noted here is, listen to this carefully. Angle between R1 vector and R2 vector according to this diagram is delta theta. Right? But if you see, v1 vector is actually perpendicular to R1 vector. V1 vector is actually perpendicular to R1 vector because I put OA vector is R1 vector. Here also you have OA, which is R1 vector. Similarly, OB vector is R2 vector. So if I put this as a vector, then V2 vector is perpendicular to R2 vector. Right? So if the angle between, listen to this very carefully. If the angle between 2 vectors is theta, then the angle between their corresponding perpendiculars will also be theta. Meaning, if the angle between R1 vector and R2 vector means from R1 vector, if I take the rotation towards R2 vector as delta theta, then the angle between V1 vector and V2 vector means from V1 vector, if I take the rotation towards V2 vector, that will also be exactly delta theta. So you can make a note of this one. Clear to this? Right. You're done, I'll proceed. Shall I proceed? Now, an important point to be noted here is magnitude of R1 is R and magnitude of R2 is also R. Similarly, magnitude V1 is V and magnitude of V2 is also V. So from this what I can conclude is OB and OA, that is this length and this length are the same. So this forms an isosceles triangle in such a way, if I take this angle to be X, this angle will also be X. Right? Now coming to the next triangle, V1 has magnitude V and V2 also has a magnitude of V. So this side and this side are also equal. So looking at the case here, since one of the angles is going to be delta theta, the other two angles, since they are the same thing should happen with the second triangle also. Right? So this will be X and this will be X. From this, an important conclusion that I get off is this triangle which is formed by the radial vectors and the triangle which is formed by the velocity vectors are similar. Congruent, they are similar. Are the same. I never told the sides are exactly the same. I never told R is equal to B. Okay. So this triangle and this triangle are similar. So using the properties of similarity, we are going to find the relation between the sides that are available to us. Observe. So if I take this to be P, Q, and R, then I can conclude that triangle OAB is similar to triangle. So the corresponding point of O, the corresponding point of O here is going to be P, and the corresponding point for A is like OA vector has R1 vector, so it's PQ vector, which is V1 vector. So P, Q, and R, they both are similar according to the APA criteria. Right? So when you have two similar triangles, an important point that you can say is their sides are in the same proportion. Their sides are in the same proportion, meaning OA divided by PQ will be equal to AB. So OA divided by PQ, OA divided by PQ will be equal to OB. Sorry, will be equal to AB divided by QR. But if you see, what is the magnitude of OA? Magnitude of OA is R1 vector's magnitude, which is R itself. So from here I can conclude that R divided by magnitude of PQ is V. So R divided by V will be equal to AB vectors. So what is AB vector? AB vector's magnitude is delta R. So it is going to be delta R divided by magnitude of QR vector is delta V. So it is going to be delta V. So R divided by V will be equal to delta R divided by delta V. So R divided by V will be equal to delta R divided by delta V, which implies that delta R divided by R will be equal to delta V divided by V. Means I just cross multiply. Delta R by R will be equal to delta V divided by V. Now, if I divide with time, that is delta T on both sides, I will get delta R divided by delta T into 1 divided by R. So I put this R outside, delta R by delta T should be equal to 1 divided by V into delta V divided by delta T. So 1 divided by V, delta V divided by delta T. Now if I limit the value, if I limit delta T to tend to 0, then what I'll get is 1 by R into limit delta T tends to 0. Delta R divided by delta T is equal to 1 by V into limit delta T tends to 0, delta V divided by delta T. Now, if you observe, this value is going to give me the instantaneous velocity. So, 1 divided by R into, this will give me the instantaneous linear velocity. So, the tangential velocity that I was speaking about is equal to 1 by V into this limit delta T tends to 0, delta V by delta T will give me the instantaneous acceleration. And this acceleration is what is called as the centripetal acceleration. So if you rearrange this equation, we can see that AC will be equal to V square divided by R. Right? Similar note, if I write AC is equal to, if we know that V is equal to R omega, if I substitute R omega here, it will become R square omega square divided by R, and this will also be equal to omega square R. From this, I can conclude that the centripetal acceleration will be equal to V square by R or omega square R. This is another way of deriving the same expression for centripetal acceleration. Make a note. Here I want to mention an important point. Okay. The one you are supposed to use in your CBSE. Don't use the one which I gave you yesterday. But here, I'm not sure how many schools they have taught this already. If they teach you already. But this concept was discussed. No, right? Okay. So this is the actual way according to NCERT. I'm not saying what I taught you yesterday is wrong. That is right only, and 200% better, 100%. But think this, that is not a part of this syllabus. I explained it so that I can prove that acceleration and radial are directly proportional to each other. Because here you say I did get a minus. Whereas in that case, I got a minus and vectors help us. Make a note of this. So on the previous slide. Next slide. So when you're writing, understand each and every step and then write. If there is any doubt, get it clarified. To my knowledge, in every school, the training lasts for 3 months. Most 3 months. Those who are online, are you clear?
Yes, sir.
That's what in the definitions I gave yesterday. For an average value, so I wrote delta R by delta T, that is average value. For that average value, if you put delta T tends to 0, the denominator tends to 0, it becomes instantaneous. So the delta T tends to 0, right? That is denominator delta T should be there. I hope this is clear. So are we ready to solve problems based on this concept? Copy. Those are online. Did you guys copy?
Yes, sir.
Get started. So let's see the first problem that is associated with this one. This is the angular velocity of our hand of a watch or angular velocity of Earth around its own axis. And after you mention which one is greater, you need to give the respective ratio. So let's see. So if I take the hour hand of a watch, right? So how much time does it take to complete one full revolution? So if I have to measure its angular speed, if I call it as omega 1, if I call it as omega 1, then omega 1 is written as theta divided by t, because it's the rate of change of angular displacement. But we know the fact that it will be able to complete 2 pi radians, that is 360 degrees in 12 hours. So 2 pi divided by 12. So 2 pi is measured in radian and 12 is measured in hour. So this is going to be equal to pi by 6 radian per hour. In a similar way, if I take omega 2, which I write it as theta 2 by t2, then I can say that Earth completes a full revolution about its own axis in 24 hours. So 2 pi divided by 24, so 2 pi is measured in radian and this is measured in hour, it will be pi by 12 radian per hour. So if you try to compare these two values, among omega 1 and omega 2, since the denominator for omega 1 is less, right? I can say omega 1 will be greater than omega 2. And if you take the ratio of them, omega 1 divided by omega 2, it will be pi by 6 divided by pi by 12. So pi and pi will get cancelled. It will be 12 by 6, which is 2 is to 1. So this is the required ratio that they are asking. 2 is to 1. Now guys can make a note of it. Let this go. Yes. For a Sham done. Make it. goes to 1. So let's proceed to the next problem. Next one asks, calculate the angular speed of driving which makes 420 revolutions per minute. So the given value here is frequency. So frequency, if you observe, it is 400 revolutions per minute. It's called as RPM. You can either call it as revolutions per minute or rotations per minute. Right? So when you need to convert revolutions per minute to second, then you need to divide this value with 60 because 1 minute is going to be equal to 60 seconds. Means it is able to do 7 revolutions per second. So it is 420 revolutions per minute. In a second, it is making 7 revolutions. Means it is revolving, it is completing 7 full rotations in 1 second. Right? If this kind of a frequency is able to be exhibited by this timing, then what is going to be the angular speed of it? That's what we are going to calculate. So if you see, omega will be equal to 2 pi f, as simple as. So the answer is going to be 14 pi radians per second. Expected value. But only thing I would like to mention here is ensure when you are reporting the answer for angular speed that you are reporting in terms of radians per second. Don't express it as radians per minute or radians per hour. Easier than just 44 radians per second. 14 into actually will multiply to 3.14. So 14 into 3.14 is approximately to 3.2. So moving on to the next problem. There is a body of mass 10 kilograms and it is revolving in a circle of diameter 0.4 meter. And during this process, it is making 1000 revolutions per minute. Again, I'm going to here. Calculate linear velocity and centripetal acceleration. So first, let us collect all the given data. So the solution here. Mass of the object is going to be equal to 10 kilogram. The diameter is given as 0.4 meter, which implies the radius is going to be equal to 0.2 meter. And frequency is given as 1000 revolutions per minute, which is RPM, or this can also be equal to 1000 divided by 60 revolutions per second. So 1 0 will get cancelled. It is going to be 50 divided by 3 revolutions per second. What is their expectation? We need to find the linear velocity. So V is equal to R into omega. So here if you see, R is capital R, and in the place of omega, I can write it as 2 pi f. So the value of capital R is going to be equal to 0.2 into 2 pi into what is the value of f? It is going to be 50 divided by 3. So 50 multiplied with 0.2 is going to give us 10. So 10 into 2 is going to give us 20. So 20 pi by 3 meter per second is going to give us the. In a similar way, if I need to find the centripetal acceleration, it is going to be equal to v square divided by r. So v square is 20 pi by 3, the whole square, divided by r is going to be 0.2. So this can be written as 400 pi square divided by 9. the whole divided by 0.2 can be written as 2 divided by 10. So you write it as 2 by 10. So this will cancel it 200 times, and the 10 goes to numerator. It will become 2000 pi square divided by 9 meter per second square. So this is the required answer. But if you observe, so mass of the object is not needed, it is given only to confusion. Okay. For example, if I have to modify this question and ask you, instead of saying centripetal acceleration, ask you centripetal force, then what you need to do is find the acceleration and multiply with mass according to Newton's second. Okay, at that point it will be useful for us. Here it is of no use. Multiplied by 3 is the linear velocity, and 2000 pi square divided by 9 is the centripetal acceleration. Here, so moving on to the next problem. Find the magnitude of the centripetal acceleration of a particle which is revolving on the tip of a fan blade. Diameter is 0.3 meter, and the fan blade is revolving at a speed of at an angular speed of 200 revolutions per minute. So let's collect the given data. So if you look at the solution here, there is a fan blade, and at the tip of it, you have a particle. Since the diameter of the fan plate is given as 0.3 meter, its radius is going to be 0.15 meter if I consider this to be the center. And this is the tip at which the particle is placed. And the particle is actually revolving in the horizontal circular path. This is how the fan plate is. There is a particle here. It's called as horizontal circular motion. Having this in mind, let's try to find out the centripetal acceleration. So AC is equal to V square divided by R is one of the formula, or I can also use omega square R. I would prefer the second one here because they are given frequency and it is easy for me to write the frequency in terms of angular frequency. So AC will be equal to 2 pi f the whole square into R. So which is going to be 4 pi square f square into R. So let us say this is the formula for this particular problem. Okay. So every data is given to us. If you see frequency is given as 1200 revolutions per minute, which is going to be 1200 divided by 60 revolutions per second, which is going to give us 20 revolutions per second, right? In a similar part, R is equal to 0.15 meter. Take these two values and plug it together, you get that. So AC will be equal to 4 pi square into F square is going to be 400 into R is 0.15, which I'll write it as 15 divided by 100. So these two zeros will get cancelled. 15 into 4 is 60. 60 into 4 is going to give me a 240. So 240 pi square meter per second square is going to be the required centimeter acceleration. Any doubt? Penna? Shall I proceed? Moving on to the next one. So there is a circular group, something revolving a circular path. There is an insect which got trapped in the circular group, and the radius of the group is given as 12 centimeter. So radius is 12 centimeter, and it is moving along the group. So as the group is revolving, obviously the insect which has got trapped also will revolve because it doesn't have any freedom in the motion. So it has to follow whatever the circular group is going. Right. So it moves along the circular group steadily. Steadily in the sense it is having a uniform motion. So steadily and completes 7 revolutions in 100 seconds. So if you see the frequency, it is completing 7 revolutions in 100 seconds. Right. But I cannot write 7 by 100 because I need to define the frequency as number of revolutions per second. So in 1 second, how many revolutions is it going to get completed? So if you see, that will be equal to, if I call this as x, then it is equal to 100x is 7. So frequency will be opportunity UST. 7 divided by 100. Okay. So it is 7 divided by 100 revolutions per second. Then 7 revolutions per 100 seconds. So 7 by 100 will be for 1 revolution. Is the point clear? Now, what is going to be the angular speed? So angular speed is omega. So omega will be equal to 2 pi into f. So 2 pi into f is going to be 7 divided by 100. So it will be 14 pi divided by 100 radians per second. So it is equal to how much? If I have to write it in the simplified manner, I'll write it as 7 pi by 50. So 7 pi by 50 radian per second is going to be the required angular speed. Oh, the angular speed, will I be able to calculate the radius speed? Yes, I can do it because I have the radius in my hand. So V is equal to R omega. So R is 12, but 12 is in centimeters. So I'll write it as 12 into 10 power minus 2 meter multiplied with omega is 7 pi divided by 50. So this will go 6 times, this will go 25 times. So it is 42 pi divided by 25 into 10 power minus 2 meter per second. So this is the answer for the first part. Moving on to the next part. Is the acceleration vector a constant vector? Read the point carefully. Is the acceleration vector a constant vector? We need to understand the point. And they ask, is the acceleration a constant value? Yes, it is. And that acceleration is centimeter acceleration. But they ask, is acceleration vector a constant vector? It is constant only in terms of magnitude, but not in terms of direction. Because when you take the r, if suppose the particle is at point A, B, and let's say at C, at point A, it will be directed in this way. At point B, it will be directed in this way, and at point C, it will be directed in this way. Because at every point, the acceleration is directed only towards the center. Right? So, as a vector, it is not constant because the direction is changing. But as a scalar value, that is in terms of magnitude, yes, it is constant. And its value is how much? It is v square divided by r. That is going to be the magnitude of the acceleration. And the third part that they have asked is, what is the linear displacement? So for me to find the linear displacement, first I need to find what is the angular displacement that has taken place. So how to find it? What is its linear displacement? Because for me to find linear displacement, I need to know the angle. For us to find the angle, we need to know how much time it has taken to go from a point to another point. Take 100 seconds as the time. Complete 7 revolutions. So if they are saying in 100 seconds how much is the linear displacement, then it will be easy for us to find. So what we need to do is, first we'll find theta. Theta is equal to omega into t. So what is the value of omega? Omega is 7 pi by 50 into the time taken is going to be 100 seconds. So when you cancel these two, you will get 14 pi. So what I'm trying to tell you here is, in 100 seconds, the particle has completed a revolution of 14 pi radian. Okay. So to complete one revolution, it takes one time period. So one revolution is 2 pi radians. To complete 2 pi radians, it takes one time period. So to complete 14 pi revolutions, it takes 14 times. It takes 7 times time period. So it takes 7 times time period. But we know that 7 into time period is 1 by frequency. So 7 divided by what is going to be the frequency? 7 divided by 100, which is going to be 100. So it has completed 100 revolutions in 100 seconds. Okay. They didn't ask you the number of revolutions. They asked us the linear displacement. So for linear, it completes, see, it will be able to complete 14 pi radians in how much time? In 7 seconds. So, sorry, 7 time periods. So 7 time periods is able to complete 100 revolutions. But S is equal to R into theta. You remember this? S is equal to R theta. This you would have learned in your trigonometry also. So R is how much? 12 into theta is 14 pi. So if you multiply this 12 with 14, how much are you going to get? So 196 minus 28. 168. So we get 168 pi meter. So this is going to be the linear displacement of the particle in the time interval of 100 seconds. Okay. First, let me check the answer, then you can make it. I calculated the linear distance. Actually, linear displacement is 0. Because after 7th revolution, the particle, the insect would have come back to the same point. So linear displacement is, I'll tell you, whatever I calculated. Okay. So this theta, I have calculated how many revolutions has it completed. Obviously, it would have completed 14 by revolutions. Because in 1 second, how many revolutions is it completing? 7 by 100 revolutions. In 100 seconds, it would have completed 7 revolutions. So each revolution constitutes to 2 pi radians. So after 7 revolutions, how much will be the angular displacement? 7 into 2 pi, which will be 14 pi. Mostly these kind of problems we do in a chapter called as rotational mechanics. So I thought they wanted to do something like that, and I did that. Right. I missed it. It was my mistake. So linear displacement is 0. Because after the completion of 7th revolution, the particle will come back to the same. So obviously, the particle comes back to the same point where it started. Displacement is 0. But distance, how much is the distance? What is the total distance traveled by the insect? It is 168.5 meters. Because of the 7 revolutions it has. Because it has completed 100 revolutions. Here, so make a note of it. Done. Shall I proceed? Yeah. So I hope last part you guys didn't copy. Would have wrote displacement is 0. So the next problem is the radius of the Earth's orbit around the Sun is 1.5 into 10 power 11 meters. How much is it? 1.5 into 10 power 11 meter. Calculate the angular and linear velocity of the Earth. So how to calculate the angular velocity? So they are given only radius. So how do I calculate angular velocity? Time period of Earth. What is the time period of Earth? It is going to complete one revolution in 24 hours about its own axis. 1 minute. It's 360 because I calculated about it. So because they did okay. So the radius of the Earth's orbit around the Sun. So since they mentioned around the Sun, it takes 365 days to complete one revolution. So 24 hours is the time taken for the revolution of the Earth about its own axis. Here, Sun is also important, right? So what is going to be the answer? 1 minute. I need to clear this data. Just see how it goes. So coming back from the beginning. So the radius of the Earth's orbit around the Sun is 1.5 into 10 power 11. 1.5 is 1.5 into 10 power 11 meter, which is the radius. But time period is going to be how much? 365 days. So can you convert this 365 days to seconds? So 365 into 24 hours each day into 60 minutes into 60 seconds. So 24 into 60 into 60 is going to give you 86,400 seconds. That is a famous number. So 365 into 86,400 seconds is going to give you the time period. Since you know the time period, now it is easy for you to calculate the frequency. So 1 by frequency is what is time period. So implies frequency is 1 divided by 365 into 86400. Right? So these many second inverse. Generally, the unit of frequency is second inverse, or it is also called as hertz, which is written as capital HZ. Okay. So once you know the frequency, you can calculate the angular velocity. Angular velocity is equal to 2 pi into f. That is going to be 2 pi into 1 divided by 365 into 86,400. So these many radians per second will be the required answer for angular velocity. What about linear velocity? So V will be equal to R into omega. So V is equal to R is how much? It is 1.5 into 10 power 11 into omega is going to be 2 pi divided by 365 into 86400 meter per second. Right? Now the next question is, to what angle or to how much angle does the Earth revolve in 2 days? So this angle theta, they're asking how much angle would it subtend at the Sun after 2 days of time. So in 365 days, it is completing a revolution of 2 pi radian, one revolution around the Sun. So in 2 days, how much will it complete? 2 divided by 365 into 2 pi, which will give you 4 pi divided by 365 radian. This is the amount of angle it would have covered in 2 days of time. Let me check the answer once. Yeah. Make it open. last problem of the day. And on Sunday's test, I have not tested circular motion and relative velocity. These two are not tested. You have till projectile motion. Okay. Last problem. A particle moves in a circle of radius 4 centimeters clockwise at a constant speed of 2 centimeters per second. So given information is the radius is 4 centimeters and it is revolving in the clockwise direction with a constant speed of 2 centimeters per second. If x and y are unit acceleration vectors along the x-axis and y-axis respectively, find the acceleration of the particle at the instant halfway between P and Q. So between the point P and Q, there is a point somewhere midway. So when I say somewhere midway, the particles are actually revolved. So how much of the angle it has covered? 45 degrees, because it will be an angular bicycle. So when it is 45 degrees, we need to find what is going to be the acceleration of the particle at that distance. So acceleration of the particle is going to be equal to v square divided by r. Right? So it is revolving with a constant speed of how much? 2 square divided by the radius is going to be 4. So it is going to give us 1 meter per second square. Yes. So the answer to this question is 1 meter per second square. But they are not expecting the answer in terms of scalar value. They are not expecting the magnitude. They are expecting the vector part of it. Means if I have to write AC as a vector, then it is going to be AX minus I cap. So actually this will be X and this will be Y. So AX minus I cap plus AY minus J cap. Because the acceleration is in this direction, acceleration along X direction will be in this way, and Y direction will be the downwards. Right? So acceleration along X direction is going to be equal to, if this angle is 45 degrees, this will also be 45. So A vector can be resolved as A cos 45 degrees here and A sin 45 degrees here. Right? So AX will be A cos 45 degrees of minus I cap in the direction of minus I cap plus A sin of 45 degrees in the direction of minus J. So it is going to be A divided by root 2 of minus I cap plus A divided by root 2 minus J cap. But the value of A we have already found, it is 1. So 1 by root 2 of minus I cap plus 1 by root 2 of minus J cap. And this is going to be the required acceleration for this question. Centimeter per second. Here it should be centimeter per second square. So here also it means centimeter per second square. with this, we end the session. Okay. So go and prepare for this. Tomorrow's have. Yeah. Smaller case, one is the case. One is smaller case, one is upper case. Then it. Okay, so online will wind up.
Thank you, sir.